Okay, this is 12.6 notes, exponential regression notes. So it says exponential regression may be used to formulate equations of exponential functions of the form y is equal to a times b to the x power, where a is the intercept, so the y-intercept, and b is the slope. Okay. So another way that they refer to a is the initial value. So this is where the equation starts. And then we can remember that slope is always going to be the change in y over the change in x. Okay, so whether or not this is going to give us a growth, so b is greater than 1, or a decay, b is less than 1, but greater than 0. We need at least 3 points to formulate an equation for an exponential function using this method. Points can be found on a table, graph, or description, so like a word problem. And in order to do these, a lot of this is just done purely on the calculator. So here are the steps on the calculator. These are steps that you're going to have to memorize. You will not be given them on the exam. So using your TI Inspire, the very first thing is you would go to List and Spreadsheets. Once you're on List and Spreadsheets, you're going to label your A and B spots, X and Y, and then you're going to fill in the data. So whatever data is there, you're going to fill in. Then you're going to make sure that you are on a blank spot, so one of those white blank spots. And then you're either going to hit Control Doc or you can hit Control I, and that's going to open up a new document. And that document you're trying to open is data and statistics. And what this does is it takes all the data that you plotted in the table and it graphs it for you into a scatter plot. And in order to make sure you are doing this correctly, you have to make sure that your X and your Y variables are on the correct axes. So X is on the bottom and Y is to the left. And then lastly, you're going to find the regression equation by going to Menu, Analyze, Regression, and then Exponential. So what this is Menu 4, 6, 8. That's all you need to remember. We're always going to use exponential because that's what the notes are about. Okay, so I'm going to go through these examples, and I'm not able to show the calculator side by side, so I'm just going to mention when we're using the calculator and where you would go on the calculator to answer this. So example 1 says a general merchandise retailer has a total of 420 open stores in 1990, 977 in 2000, and 1682 in 2008. It says complete the table. Use exponential regression to write an exponential function that can be used to estimate the number of stores opening X years after 1990. So notice it starts to fill in the table for us. It has 0 and 420. Well, it's referring to 0 as 1990. So our next opening would be 2000 is 10 years after 1990. So I'm going to use X equals 10. And then the next one is in 2008, which is 18 years after the initial opening, and that's 1682. So I'm going to follow the steps above. And when I do that, we get the equation y is equal to 429.20 times 1.08 to the power of x. Part B says interpret the meaning of B within the context of the situation. So remember our formula, we ignore the 1. So we're only looking at this 0.08. Well, 0.08 as a percentage is 8%. And since it's positive, it's greater than 1, we know that 1.08 is showing us a growth. So we would say the number of open stores is increasing by 8% per year. Then it says, use the regression equation to predict the number of stores in 2020. So we're using our equation that we found, and then we have to think, okay, 2020 is how many years after 1990? Well, that's 30 years between 1990 and 2020, so I'm going to plug in a 30 into my x value. And then I'm just going to plug this entire thing into my calculator, and I get 4,319. You may get a decimal when you type that in. Just know we're talking about stores, and you can't have a percentage of a store, so always just round up. Okay, number 2 says the total annual sales of a company can be modeled by the exponential function. A sample of the company's annual sales is shown on the table below. So you would follow all the steps above to find your equation, and you would get y is equal to 464.409 times 0.978 to the power of x. It says the table shows the total annual sales from 2012 was 348.7 million. So it's talking about this one right here. Compare this value to the total annual sales for 2012 predicted by your regression model. Why are the values not exactly the same? So 2012 is 12 years after 2000, so I'm going to plug 12 in for x. Y is equal to 464.409 times 0.978 to the power of 12. I'm going to plug that into my calculator, and I am going to get... I don't quite remember. I think it's 355. I think it's somewhere along those lines. And of course, you can correct me if I'm wrong. I know that the numbers are just a little off. Okay. And the reason for that is that the number that is in the table is what actually happened. So this is the actual value. Okay. And what we found is the predicted value. Okay, this is what we would expect to happen. And this is what actually happened, so the observed. Okay, so the reason why they're different is because the whole point of a regression model is to make a prediction. So let's say we were making a prediction for a year that has not happened yet. So for example, 2035. Well, in 2035, we don't know how much those annual sales are, but we could plug in 35 in for x and get a predicted value. The only reason that these values are different is because 2012 has already happened, and they already observed that the annual sales was 348.7 million, okay? Since this value is a little lower than predicted, this is when it starts going into talking about residuals and that difference, and this leads us into calculus. So if this looks interesting, maybe you'd be interested in taking AP or dual credit statistics. So again, I would write down that the regression model is only a prediction, not the exact amount. Okay, and then example 3, it wants us to use our calculator to find the regression models for a table and a graph. So for the table, you would plug in all these values into the table, and you would get the equation y is equal to 465 times 4.5 to the power of x. And then for the graph, you would have to notice that, okay, we have our 3 points there, but I need to take those 3 points and create a table of points so I can put this into lists and spreadsheets. So this first point here is 0, 1. Then I have 1, 3. And then I have 2, 9. So I would plug in all those values into my calculator, same way I did in all the other ones, where I start with lists and spreadsheets and then put it into data and statistics to get my linear regression model. And I would get y is equal to 1 times 3 to the x power, which is the same as saying y is equal to the 3x power.